Okay, let's do problem 8. The first. So in problem 8, we are given f function, then we are given g function, and we are asked to find out what is f circle g, and then the differentiation of f circle g at a particular point. So first let's write it down. F u w is equal to e power u minus w, comma cos of v plus u plus sine of u plus v plus w. And then g of x comma y is e power x cos of y minus x, and then e power minus y. So now that we have written this, let's see how we do the first part, which is f circle g. So f circle g of x comma y is basically f of g of x comma y. So this is f of g of x comma y. I'll just write it down, which is e power x cos of y minus x, e power minus y. Now in this is your u part, this is your v part, this is your w. So if I just expand this in your f of u v w, you will get it as e power x minus e power minus y. Then you have cos of e power x plus cos of y minus x plus sine of e power x plus cos of y minus x plus e power minus y. All I'm just doing is just substituting u, v, w with e power x cos of y minus x and e power minus y. Yeah, a part is very simple, straightforward, should not be any issue. Let's see on how to do the b part, which is finding out d of f circle g at the point 0, 0. So we know by the chain rule that this is d of f of g of 0, 0 matrix multiplied with d of g of 0, 0. This is one matrix, this is other matrix. We need to find out both the matrices. So let's see what is first g of 0, 0. In this equation, if I substitute x equal to 0 and y equal to 0, I'm going to get it as 1, 1, and 1. So the first step is finding out this matrix. So first I'll find out what is g of x comma y. So if I take the partial derivative of this, on the right hand side, you can see that there is, so it's basically from r square to r cube. So my partial matrix is going to be like a 3 cross 2 matrix. So a 3 cross 2 matrix. So in the first term, I'm going to, take this part, differentiate with respect to x, and then differentiate with respect to y. So if I differentiate with respect to x, I get e power x. If I differentiate the same term with respect to y, I get 0. Then I take the next term, I differentiate with respect to x. So I get minus sine y minus x. But since I have minus x, this minus minus gets cancelled. The same term, if I differentiate with respect to y, I get minus sine y minus x. The third term, if I differentiate with respect to x, I get 0. And if I differentiate with respect to y, I get minus e power minus y. So this is a 3 cross 2 partial derivative matrix. Now let's find out the same thing at point 0, 0, because that's what we're interested in. So if I substitute x equal to 0 and y equal to 0, I get it as 1, 0, get 0, 0, 0, minus 1. So you have one of the matrices here. Now let's try to find out what's the partial derivative of your f function so that we can eventually find out what is this matrix. So d of f of u v w, if I write my partial derivative, I'm just going to write it down. You can differentiate it and see if you're getting the same answer. So this will be e power u minus w. You'll have it as 0. You'll have minus e power u minus w. we'll have minus sign v minus v plus u, minus sign v plus u, plus cos of u plus v plus w. This is like one term. The second term here is minus sign v plus u plus cos of u plus v plus w. And the third term is just cos of u plus v plus w. Okay. Now we know that g of 0 comma 0 is 1 1 1. So d of f of g of 0 comma 0 is basically d of f of 1 1 1. So if I substitute u, v, and w as 1 1 1 in my above matrix, I get this as 1 0 minus 1 cos 3 minus sine 2 cos 3 minus sine 2, and then I have cos 3. So I have two matrices, whichever I was interested in. I have both the matrices value. The only thing left is just matrix multiplying both these matrices to get your final answer. So if I do matrix multiplication of both of them, so this is what we are trying to find, which is 1 0 minus 1 cos 3 minus sine 2 cos 3 minus sine 2 cos 3 matrix multiplied with, so this is a 2 cross 3 matrix. I am multiplying it with a 3 cross 2 matrix, which is 1 0 0 0 0 minus 1. So if you multiply these two matrices, the resultant you are going to get is a 2 cross 2 matrix. So if you multiply, you're going to get it as 1 1 cos 3 minus sine 2, then minus cos 3. This is your final answer. Any
The
doubts?
one on the left has two rows
Correct.
and three columns because it has
Correct.
three terms U, V, and W.
Correct. Yeah.
And the one on the right has two columns and
Yeah,
columns
because
and
it's X
three
and Y.
rows. X
Correct.
and Y. Okay.
So we'll just follow the same step for, same way of solving for all the other questions like 9, 11, and 12. So I'll just review this. So given two functions, f and g, A part is pretty simple. I hope you guys understand that. So for the B part, this is by making use of the chain rule. Basically, I need to find out two partial derivative matrices substituted at the point 0 comma 0 to figure out what's my chained way of differentiation. So I first figure out what is my partial derivative of g. First I find out the point, then I find out what's my partial derivative of g matrix, and I substitute at the point 0 comma 0 to figure out that matrix. Then I found out what is the partial derivative matrix of f function. I figure out at the new point, which is at 1 1 1 as figured out from g of 0 0. I figure that matrix. Then I just do a matrix multiplication of both the matrices to get my final answer. Any doubts in this question? Check this in. There's nothing on the Zoom. Okay, if there are no more doubts, let's move on to the question 9. So 2.5.9. Let's see. So they're asking us to find out the partial derivative matrix, but with respect to a particular term, which is S of, so they're asking us to find dou by dou S of F circle T at 1 comma 0. So what we'll do is we'll first figure out this final matrix. We'll find out what is d of f circle t at what point. Then basically let's differentiate whatever you have here. So like one part of the column would be differentiation with respect to a particular term. The other column would be the differentiation with respect to another term. So from that we can find out the answer. Uh, so the method is going to be the same way. We figure out on how to matrix multiply both the matrices, get the final answer. But after getting the final answer, we'll just take only one column out of it because they're asking us what is it with respect to s. So let's write it down what we have. We have f of u comma v as cos u sine v, and then I have t of s comma t as cos of t square s comma log root of 1 plus s square. So they're basically asking what is the thing with respect to this partial derivative with respect to this particular term s. As you can see, it's just like one of the coordinates. So essentially, if I just extract one column out of this, I'm going to get that answer. So let's see on how it works. So the first things first, that if I want to find out d of f of t at point 1 comma 0, so this is V matrix, and I'm multiplying it with a 3 cross 2 matrix, which is 2 2 0 0 1 0, 3 cross 2. So the final matrix is going to be like a 5 cross 2 matrix, which is 7 pi 4 pi 7 e power 6 4 e power 6 0 0 2 2 0 0. That's your final answer. Just like might be slightly a bit compute intensive question, but the method is just the same method in all questions. Um, so I request you guys to do it, the right way in the first try. Otherwise, like if you make a mistake somewhere, it's highly bound to like every other step will get like messed up. So yeah, just do it carefully, because if you are very clear with the method, like just do each step in a very proper manner, and you should get your final result exactly same. So yeah, like if you do that, you should get the right answer for every question in this exercise.
Do you think that these types of problems would show up on an exam because they're kind of time consuming, like with a matrix this big?
Maybe the matrix might not be this big, but I'm pretty sure that you will get a problem in this exercise, because it's a very, as you can see, all the problems are of same type. So you'll get one problem definitely.
Just not as big as the matrix, like of a matrix.
Yeah, maybe the matrix might not be this big, like a 5 cross 3, but might be something like one of the questions which we had.
Okay.
It can be like a 2 cross 2, 3 cross 2, something like that.
Okay.
But don't be surprised if you get a 5 cross 3 matrix. But he'll make sure probably the computation is
or something.
like, as you can see, like most of the terms are 0.
Oh,
so
yeah. Okay.
It's like you figuring out the right terms.
Okay. Thank you.
Yeah, but I'm pretty sure there'll be like one question, because it's a very standard question in this chapter. Like this literally involves a lot of things. As you can see, it's involving partial derivatives, it's involving differentiation, it's involving matrix multiplication. Um, he can just combine this with a velocity vector question as well, as we already have one of the questions. So he can just combine all of these, give it as like one problem, and this is a very good problem, I would say. Like a way in which he can literally test all the concepts in one question. So chapter 2, it's mostly differentiation, and I think like this particular exercise has the bulk of the concepts that you had learned till now, in terms of the Jacobian, in terms of partial derivatives and all that. Yeah, don't be surprised if you see a problem of such type. This is my guess because like last time when I worked with the other prof, he used to give problems something similar to this. He used to give problems on tangent plane. He used to give problems on this. So, and since I saw exam one, he seems to follow a very similar pattern. He's asking tangent plane. He's asking plane equation, line equation, and all that. So I guess it's probably all the problems that irrespective of the prof, they're going to ask a very similar pattern. So um, yeah, you shouldn't be surprised if you see a problem of one type. Okay, I think we solved every question in this exercise. Was there anything that you guys found it difficult in the previous exercise? Um, I guess not, because we solved every part of the question, but yeah, that might be some issues here and there. I'll check the chat.
I had a more of a theoretical question.
Uh-huh.
So I guess just what exactly is like the final answer that we just got, like the 5x2 matrix?
Mm-hmm.
What exactly does that tell us? What exactly is that matrix?
Okay, so basically, we are trying to. So they're giving us two functions, h function and g function. We are trying to map both these functions together, like a fusion out of these two functions. We are trying to map both of them, and then we are trying to find out the differentiation of that particular fused function. Okay, so this is the objective. There are multiple ways to do this. Like if you see some previous questions, right? Like let's take the first question. In the first question, we found out what is that fused function. This is that fused function. Now, this fused function, you can find out the partial derivative matrix directly. If you consider this as one term, this as another term, this is another term, you differentiate each of the terms with respect to x, with respect to y, you will finally get like, since there are three terms, right? You'll have three rows and you'll have like two columns. So you'll have like a 3x2 matrix finally. This is at, oh, sorry, there are only two terms here. This is a plus sign. So this is one term and this is the other term. So 2x2 matrix is the final matrix that you'll get. But as you can see, the fuse function itself looks so complex. Like differentiating this particular term with respect to x and y, it's going to take you a lot of time. It's not that easy to just do a partial different derivative of this with respect to x and y. So in order to avoid the brute force method, so we make use of differentiation chain rule. So this chain rule, what it basically says is, whatever is that inside function or the function which you're trying to fuse it with, find out the partial derivative of it separately, and then now whatever is the point that you get from the first function, use it as input to your second function, and then find out the partial derivative of that separately. And then if you just do a matrix multiplication of both of them, you will get a same answer as that of your chain rule. So this property, it's a very mathematical property. I'm not very sure of the proof of it, but ultimately of you trying to find out the derivative separately used by making use of the fused kind of way, which is more complex. You can, of course, you can try it yourself. You can find out the differentiation of this partial derivative, and you should get the same answer as this. You should get the same answer. So you can do it as well, but it's going to be more time consuming, more prone to errors and all that. So this particular section provides a method for you to find out the partial derivative. So this is that method. Like they are just given like various special cases of the chain rule. So you can just look over this and see like on how exactly that proof basically works. But you know, in a nutshell, like they are trying to avoid the differentiation in a much more complex way. If you just do it brute force, it's going to be more complex. So that's why we make use of the chain rule to figure out the differentiation of a fused function.
Okay, that makes sense. So it's like the matrix description of the
Yeah, so it's
surface,
basically
I guess,
the
that we have with the
yeah.
okay.
Correct.